Hello, and welcome to AV Cyberactive. Hi, I'm Avinash. In this course, I'll be discussing the difference between authentication and authorization, where authorization follows successful authentication. I'll also cover how authentication and authorization are related to web application security. Next, I'll explore how to hash and encrypt user credentials and how to harden user accounts through Microsoft group policy. I'll then examine how to use freely available tools to crack user credentials in various ways, such as using the John the Ripper tool to crack Linux passwords and the Hydra tool to crack RDP passwords. Lastly, I'll cover how to enable user multi-factor authentication and conditional access policies, as well as how to mitigate weak authentication. Let's get started. The concept of authentication and authorization is an important one in IT security, but we have to go beyond just the concepts. We have to start with the concepts, but what's important is to implement security controls related to hardening our environment by increasing security for authentication and authorization. So, authentication means proof of identity, and there are so many ways that one can be done. But we need a way to ensure that the users or devices authenticate to a network, to a website, or to a host that they are who they say they are, and it's not a stolen identity. Now, after we have authorization, this occurs after successful authentication, and really all it means is having the appropriate access to a resource based on the assigned permissions to that resource. So perhaps you remember of a group, and after you sign in through that group, you have permissions to access resources, files, database, web applications, cloud resources, or maybe attribute-based access control in this place. And once you've signed in as a user account, date of birth or whatever you are as a contractor versus a full-time employee or region you're in, any of those items, those attributes could be checked or to determine what you have access to. So authentication that begins with the common standard username and password. Although this is this is single factor authentication because these 2 times fall under one category. The category is something you know. Both of these can be guessed remotely from another part of the world, so it's not considered the best security. Certainly having complex password is still very important. For you, could also have a key fob authentication. A key fob is a small device that you can use in conjunction with the username and password, for example, to authenticate to a website or to a network, to a particular host in a network. So it's pretty general term, but often the key fob might generate a PIN number that is synchronized with a server-side component, which would allow you to authenticate successfully. These days, that might come in the form of an application or a smartphone, but of course, you could always have a physical key fob. As a security device, biometric authentication means that we are authenticating somebody based on their physical characteristics, whether it's their speech or voice pattern, facial recognition, or fingerprint authentication. Decades ago, this was the stuff of the James Bond movies, but these days we all know that the latest iPhone or Android easily authenticates you with a facial recognition or a fingerprint scanner. Of course, it's just not the phones, but that's just an example. It's become standard, and then we have the PKI or Public Key Infrastructure certificates, which can be used for authentication. PKI certificates are issued to an entity like the user or a website or a client device that needs to authenticate to a VPN. That certificate is required for successful authentication, whether it's only the certificate that's required or the certificate in addition to something else like a username and password. It really depends on the configuration. Now, to determine that authorized permissions, authenticated entities have given permissions to security principals. A security principal would be something like a user account, or it could be a device. So giving permission to users gives them access to resources once they are signed in. Giving permission to a device, depending on how it's done, might give permission to a resource regardless of who's using the device, or in combination with a specific user they only have access. It depends on how it is set up. Once again, in the Microsoft Azure cloud, as an example, we have a service principal, which really represents registered applications in the Azure application or the Azure Active Directory environment. You register an enterprise application, you get a service principal, you can then assign permissions to it. You're given a permissions to the application, maybe to talk to a database and a special service of a service principal. It is a managed identity where you might enable this for things like storage accounts in Azure Cloud or in virtual machines. It just allows you to give permission to a resource like a storage account or a virtual machine. You can't talk about authentication without at least mentioning multi-factor authentication or MFA. Now, we know that something you are is biometric authentication. We mentioned it's based on some kind of a physical attribute. Something you know is the standard username password combination that's just been there for decades. Something you have, whether it is a key fob or maybe a smartphone with a specialized application installed on it for authentication. That application might be Google Authenticator or Microsoft application, for instance. Then there is gesture-based authentication, something you do, a certain type of movement or pattern, and we could go on to this with this, and such as somewhere you are. It could be a kind of a global localization aspect to the authentication in the Microsoft Azure cloud. As seen in the screenshot, we have the option of selecting users in the box on the left, and then we could choose to enable multi-factor authentication because the rightmost column will show us whether the state of multi-factor authentication for the user is disabled or whether it's enforced or enabled. Enable means we have turned on multi-factor authentication for the user account, but they have not yet signed in, and so it's not actually being enforced yet. And we know that authorization happens after successful authentication. It's the permissions to access a given resource. In the case of Azure Cloud, maybe an authorization is to use the Azure portal to manage cloud resources, or a storage account key to access everything in a storage account, or a storage account shared access signature or SAS to access a subset of items in a storage account. Authorization could give you cloud-based or on-prem based application access, or it could be files on a file server to access certain video camera feeds. The list goes on and on and on. So understanding authentication and authorization is key, but more importantly, knowing how to implement the proper security controls related to these items is what we really want to focus on. The OWASP Top 10 for 2021, item A07, is entitled Identification and Authorization Failures. Let's go ahead and talk about broken authentication types of attacks. What should we watch out for in a web application that is related to hardening authentication? So the first thing we have to think about is the broken authentication really stems from the insecurity or identity and access management, or IAM configurations. Now that's a general statement. We're going to dive into more detail just on that. So what needs to be done? There needs to be a periodic reviewing of authentication methods in use and security controls in place. That's always true. There needs to be a security program to ensure the safety of our web application. Make sure it's hardened. We need to perform vulnerability assessments and penetration tests periodically. Now the standard way that the web app authentication will occur is the user will sign in, and that might be through a third-party identification partner, or it could be just part of that web application. Next, a session is created with the web application. Now what happens is that the session ID is stored in a cookie file or on that user's client device. Normally the session ID is generated server side and is sent back to the client as a cookie item. Now if the cookie has a HTTP only flag set on it, it means the client's JavaScript will not be able to access the cookie. In other words, it's designed only to be sent to the server. And so if the user browser is compromised and there's malicious JavaScript running on the client side, it won't ever have access to the cookie to be able to do anything on it. So when the user device makes a request to the web application on the server side, the request session ID, which is sent to the client device, is compared to the server session ID to ensure that they match and it hasn't been tampered with. So web application developers then need to take the code, the web application, so that the session ID is destroyed when the user logs out. So authentication vulnerabilities would include things like plain text network authentication. There are some old protocols that still show up as being in the use periodically. Things like Telnet or FTP, and if they are used in conjunction with sensitive application containing sensitive data, it could be a problem, because plain text network authentication means literally everything is sent over the network in plain text. So If a particular or malicious actor can put themselves in the network path and capture the traffic, they can read things like username and passwords with absolutely no challenge at all. Now that's being sent over the network. Then there's a storage of credentials, such as on a Linux server. If we are storing credentials on a plain text, or if we aren't using salt randomized values to make password cracking attacks more difficult, then this is also considered to be an authentication vulnerability. Moving on, we have got things like publicly exposed admin web pages. Admin web pages are normally used for admins to make changes, global setting changes to the web application to control the functionality or to control user access. We want to make sure that they are limited, and ideally there shouldn't be any easy ways to get those pages. So, or maybe those pages are to be running on a separate server that is only accessible after VPNing into the network. You probably do not want to expose to the public internet. Also, not having a account lockout settings is a problem. A great way to mitigate password cracking attacks, where attackers will enumerate user accounts, try a bunch of different passwords, is to enable account lockout. Maybe because after 3 incorrect login attempts in a short period of time, the account is locked out, maybe for 30 minutes or 60 minutes or whatever the security dictates. Now, pictured on the screen, we've got some wireless router configuration where the bottom under remote management, we can opt to enable remote management. Now, this is generally frowned upon. You don't want to expose admin interfaces to the public internet, for example. Instead, you might want to set it such that the remote management is only possible after being placed in a private network, and that might only be possible after establishing a VPN connection. So there's an additional layer of security there. Now, these days, username and passwords are still used a lot, although multi-factor authentication or two-step verification, as it's sometimes called, is still gaining popularity. It's gaining traction. So we want to make sure that we don't have easy to guess passwords or easy to guess answers to secret questions, such as a year someone graduated from school or might be publicly available in social media. Another vulnerability would be not using multi-factor authentication or login messages exposing too much information, such as the fact that if the username and password is entered, if the message returned upon on the attempt to log in, password is incorrect, well, the attacker would know that the username is incorrect. We talked about session IDs and web applications. We want to make sure the session IDs are kept hidden and not just hidden from the field or a web page that's still not considered secure. It is still can be exposed. We definitely don't want to expose session IDs in the URL string, such as having a URL that has the session ID exposed directly, because if the attacker gains access to the session ID, they might be able to perform actions on behalf of the user that the session ID is tied to. In this demonstration, the focus will be on to hash credentials. Now, some Unix and Linux operating systems by default will hash user credentials and store them in a file. Let's examine a little bit here. So here I'm using Kali Linux, but really it could be any distribution of Linux. I'm going to start here by charging directory to /etc, and you'll find most config files either in this directory or in the subdirectory. One of the things I want to focus on is a shadow file. Let's clear the screen. So I'm going to cut the shadow file. I'm going to pipe that to more to stop after first screen full of output. Now I get a permission denied, and that's because this is a second file. It contains important secured hash passwords, and so I need to run as you do in front of that to run this as an elevated or privileged command to run it as root directory, basically. So as you do cat shadow and again pipe it to more, and this time it works fine. It's asking for my current user password. I'll enter that in. So what we are looking here is a list of user accounts along with some password expiration information, but in the second field we'll have a representation of hash passwords if any exists. For example, if I look at Kali user, way towards the bottom, each field is separated with a full colon delimiter. What follows is the second place is the hash passwords for the user Kali. Now the password is actually Kali, and the Kali is resulted in this hash. So when the user specifies username Kali with a password of Kali, the password of Kali is passed through the same hashing algorithm that generated this hash. And if the hash matches, it means that user knows the password. So let's add a username account here. So I'm going to go ahead and run su do user, and we are going to add a user C Blackwells. So if I were to tail the /etc/password file spelled PSASSWD, this contains user account information as well as things like user ID, the ID of their primary group, their home directory, but it does not contain their password. That's the shadow file. Okay, so let's look at you because the shadow file is protected. Now we are going to run in to show us the last couple of lines in /etc shadow file. So C Blackwell is here, but we have in the second is an exclamation mark. In other words, there is no password. So I'm going to run as do password spell PASSWD for C Blackwell. We're going to set a password for that user account, and I'll then retype to confirm it. All right, we get a message here. The password was updated successfully. So let's use the password key to tail the etc shadow file once again. Notice this time in the second position, we have the password hash for C Blackwell. So if I were here to log in as C Blackwell, I can do that with su, the switch user command, and I'll put in dash, which means I want to run a full login environment for that user, which could mean executing scripts, and I'll specify username for C Blackwell. If you don't specify username, you're switching to root user, so you would know the root password. Well, I know C Blackwell's password, so I just left it out here. So when I enter the password here, it's going to be fed through the way to the hashing algorithm compared to the etc shadow entry for C Blackwell. Now if it's good, then it will be logged in. So if I type who am I, indeed I am successfully logged in as a user C Blackwell. I'll just type exit and get back to my regular Kali user screen account. Now another way for the password hash for the user is affected is when you log the account. For example, if I run su do user mod to modify C Blackwell in the user I want to change, I want to use the -L to log the account. So let's tail etc password once again. Well, that hasn't changed. It's just a regular user account file, so no password here because that is in shadow. So let's tail /etc shadow to see if anything's different. Now let's run su do tail /etc shadow to see if anything's different. Well, what's interesting here is the C Blackwell's password hash just begins with an exclamation mark here. The exclamation mark implies the password hash been invalidated in this case because the account is locked. If I were to run su do mod C Blackwell -u to unlock, let's clear the screen and let's tail etc shadow file once again. Notice the exclamation mark at the beginning of the password hash disappeared. Now we are back onto having valid password hash for C Blackwell, which of course will allow authentication by that user. Modern password hashing, such as with most distributions of these Linux these days, will also use salting. Salting also adds some randomized data to make sure more difficult to try to crack password hash. Traditionally, what has been used to crack password hashes is called rainbow table. Here I've going to go to freerainbowtables.com, and we have got all kind of variations of different passwords of rainbow tables, which mixed with alphanumeric with spaces or symbols and passwords. Essentially what we have here is pre-computed hashes we can compare to what, for example, in the etc shadow file, but in the rainbow table we also have the origin password that resulted in that hash. So we could download these password hashes if we are a malicious attacker and compare them to password hashes, which would one way to crack what the original user password was. A crucial part of securing today's network communications is encrypting those communications, or at least encrypting stuff that is sensitive, like log-on credentials, or maybe encrypting entire sessions, or maybe putting everything through a VPN tunnel, which means it's encrypted. In this particular case, when it comes to encrypting credentials over a network, we're going to start by talking about SSH, or Secure Shell. Here in the free Wireshark packet capturing tool, I've got an SSH packet capture. I can actually filter for SSH by typing SSH as a protocol in the bar at the top. It turns green and then I press enter. So all I'm doing now is looking for SSH traffic. I've got the source and destination IP addresses. I've got the length of transmission, a bit of information. Of course, if I select any one of these packets down below in the center, I can expand the packet headers. So I've got the Ethernet header. Now here what we have got is the source and destination and MAC addresses. We have got IPv4 protocol being shown as being the next header. Now remember that MAC addresses is a 48-bit hexadecimal unique addresses assigned to a network interface, but the MAC addresses is only locally on the local network. So the IP address allows us to talk to a device on a network. So following the Ethernet header, we have Internet Protocol or IP header, and if I expand that, we have a number of fields like the version, in this case version 4, the total length of it is particular header in this case. And if we go down further, we have things like the time to live, or the TTL value in the IP header. It is set differently depending on the type of device or operating system, but what is consistent is that each time this transmission goes through a router, the routing device would decrement the TTL value by at least 1. Once the TTL value has been decremented to nothing, then the packet is discarded and is no longer routed. The IP header also specifies that in this case, next higher level header is IP, TCP, and then of course in the IP header we have source and destination IP address. So notice so far that none of this is encrypted. We have not encrypted, at least with this transmission, the packet headers. And notice we have selected up on the top is an SSH v2 transmission, which does allow encrypted secure communication and just doesn't encrypt packet headers. Let's continue on though. Let's take a look at the TCP and transmission control protocol header. In the same way, we have got all of the fields here. So the source port is a higher level port of the client. The destination port here is 22 because that's normally what SSH listens on by default. Then we have a number of other fields that are available. The point is that the TCP header is also not encrypted. Then we are starting getting down into some details like actual payload of this transmission, where if we start selecting some of that, we get sense here some different cipher information is being exchanged. Normally what happens is when the client talks to a server of some kind, they negotiate what type of protocols they each, whether it is like for hashing SHA-1 or whether it is triple S or AES-128 for encryption. And finally, as I actually go down and drill down into the SSH protocol header, it is at this point of time we realize that we can't make sense of what actually is happening in the transmission down at the data portion of the payload. And if we start selecting varying packets, the same thing will be true. It just looks like a bunch of different characters. Now then you might see some ciphers reference, but this is an encrypted transmission, so we are providing confidentiality over SSH through the encryption and managing devices through Secure Shell or SSH. But SSH isn't the only way to encrypt credentials over the network. Still in Wireshark, here I've gotten a different packet capture open up here. So what I want to focus on here is the SSL on transmission layer security, TLS. So whether we have a different type of transmission here, TCP transmissions, but eventually we will get to a point where we have some TLS version 1.2. Now, versions of TLS prior to 1.2 should not be used, as these are known security vulnerabilities that affect them. So what we could do is filter for TLS just here by typing TLS in the filtering bar at the top. I'll press enter. Now all we're looking at is this TLS traffic. Now we have got client hello traffic from the server hello traffic along with a certificate information. Now remember, with TLS, what we really are talking about is the server sending its own public key to the client. Now we have got some exchange information happening here. So the server's public key is given to the client because the client is going to generate a unique session key, but we need a secure way to send the session key over to the server because the session key is a symmetric key. It's the same way that is used to encrypt, that is used to decrypt. Both sides of the connection must have the session key. So when the client generates it, it will decrypt the session key with the server's public key that was given, and the server will decrypt that on its end, and it will be related with its related private key. Now both parties would have that unique session key, which is further than used for encryption. So as we go through the TLS handshake, we get to a point where if we actually broke down the headers within the transmission, in this particular case it's using a loopback adapter with the device with IP version 6, after which we have a TCP header and ultimately our transport layer security TLS header. And of course we have to look at the ports that are being used here in the TCP header. In this particular packet I've selected the source port is 443. This normally is used by HTTPS, so web server stack with a certificate configured and HTTPS binding, and it's talking back to the client on a high level port, in this case 10500, but that will vary. But the point is this: as we step through, we can't really tell what's happening in the packet payload because TLS is encrypting the transmissions. In this demonstration, I'm going to be analyzing plain text transmission using the free Wireshark packet capturing and network analysis tool. And we talk about plain text transmission, where you're talking about stuff that is not encrypted. Now, that's especially a problem when we are talking about username and passwords. So credential sets or any type of sensitive information that might be transmitted. But the fact is that a lot of older network protocols or even some newer standards, if not configured correctly, still transmit a plain text. So in this case, we're going to talk about Telnet, an old Telnet standard, and it's still out there. It's in use in some cases. It is a server-side listening daemon or process. It can also be enabled on a lot of network infrastructure devices. It listens on a port 23 for remote management conditions or connections. It gives a remote command prompt on a target host as if you were at it directly typing in commands. So this used to be widely used to remotely manage things like network switches and routers and Unix and Linux hosts. But the problem is that it transmits everything in plain text. If we were able to select a Telnet packet from the packet capture and examine the headers, in this case we've got standard Ethernet header with the source and destination MAC addresses. We were using IPv4. In the case, we have got IPv4 header with all standard fields, including a source and destination IP addresses, following by the TCP header. Telnet uses TCP as a transport mechanism, not UDP, and in the TCP header we have destination port here of 23. So this is a transmission from a client going to a Telnet daemon running in some kind of a device. The source port number is always higher to talk back to a client. So if we take a look at the actual Telnet header, well, it's hard to tell if it's encrypted or not because there's nothing really happening. But what's interesting here, if we pull all the Telnet packets together for the session, so if you select one of the packets over here, Wireshark, if you go to analyze and follow TCP stream, I'll start to put it together so it's a little more digestible. And so what we have here is have a login for a test with a password of capture. We then even see some of the commands that we were typed in this case Linux host, such as uname-a to display the kernel version and then exit and then log out. We are seeing everything here, including the credentials. And really, in this day and age, there's no good reason to use Telnet. That's where SSH or secure shell kicks in because everything is encrypted. It gives us a remote command line access, and it still runs as a daemon on a server or a device. Luckily, with modern operating systems and devices, Telnet is disabled and SSH is enabled, or SSH is there and can be enabled. So all an attacker has to do is place themselves in the communication path if they know telnet traffic is occurring to capture it, but they would have to be on the network to be able to do this, and they might use techniques like ARP cache pausing and force all the LAN traffic through their host before forwarding it off to a router, and that's one way it could be done. At any rate, take a look at something else. Let's take a look at an FTP packet capture. FTP is a file transfer protocol. It has been long used for many decades as a simple way to upload and download files over the internet on devices, whether they're running Mac OS, Linux, Windows, Unix, anything. Back in the day, it might have been a Novell server, maybe it's a Windows server. Whatever the case was, FTP was a standard that was not tied to an operating system like Telnet. FTP transmits data in clear. That means credentials are not encrypted. Now, over the years, FTP connections through encryption, but standard FTP is not encrypted. So I notice if I have a number of FTP packets here, and if I select the FTP packet, we can quickly examine the header structure. So in this case, it's a loopback network adapter IPv4 followed by the transmission control protocol or TCP header, where the destination port is 21, which is normally what is used by the FTP. The source port is a higher level client port that the FTP host communicates over when it talks to the client device. Now, if we look at the payload section, it looks like we've got some legible information here for Telnet. It looks like we've got some legible information here for FTP. Why we don't filter the protocol list here at the top for FTP, we don't even have to follow a TCP stream like we did in the Telnet or anything. I have an immediate listening here with that the username is administrator and that the password looks like a variation of a word password. That's how easy it can be to view FTP credentials if you can manage to get onto the network and capture it as being transmitted. Again, the lesson is what we should not be using FTP unless we have a secure add-on on some ways like FTPS. Finally, let's take a look at the HTTP packet and capture where credentials are being sent over the network. So if I were to select some of the traffic, for example, I've got a TCP packet here. If I look at the header listing, I've got our Ethernet header, an IP header, and a TCP header. Notice the source port is 80. Well, that would be indicative of an HTTP web server, not HTTPS. That would normally be using port 443. That's interesting. So having the packet selected, if I go to analyze follow TCP stream, it's put together the entire conversation to the point that I have the username and the password shown clearly here because HTTPS is not being used to secure the connection. In this demonstration, I'll be deploying password policies using group policy in a Windows environment. You can configure group policy on an individual machine, but what we are going to be doing instead is configuring it centrally within an Active Directory domain. The benefit here is that the setting within it, in our case, password policy settings, can be applied to some or all the computers in the entire domain or all users in the domain. So what I'm going to be doing on here on my server side is go to start menu, and under Windows Administrative Tool, I'm going to fire up Group Policy Management Tool. You don't need to do this from Active Directory Domain Controller computer. You can do it from any machine as long as you are authenticated to the domain and you have the Group Policy Management Tool installed. We have a GPO or Group Policy Object Link here. We're associated with an organizational unit, OU. Here in my Active Directory domain, I have OU called East, or to organize users, group, and computers on these eastern area, but my GPO here is called East Security Setting, and if I right click and choose Edit, I could configure potentially thousands of settings on a computer configuration level. If I drill down under policies, even if I go down under Windows settings and then security settings, one of the things I can do is drill down to the account policies and ultimately to the password policy. Here's the thing. Even though you can actually go and configure this here, it will never be put into effect. The reason is because it is a GPO that is linked to the OU. So if you want to set a central group policy password setting, you need to do it in a domain level GPO like default domain policy. So I'm going to right click on it and choose edit, and we're going to drill down on the same port of the hierarchy we did previously. So compute configuration policies, Windows settings, and under security settings, and then I'll click on account policy, and we are going to into the password policy. So we have a number of settings here we can configure, such as enforcing a password history. In other words, how many passwords should be remembered. This prevents users from reusing the same password over and over again. Here it is set to a maximum of 24. So, and if I want to make sure that define as policy settings checked on, so I'll click on OK. We can also set a maximum password age. Currently it is 42. Let's say we have got a maximum number of password age is 30. In other words, every 30 days the password needs to be changed or something else. I'll click OK. The minimum password is set to 1 day. Let's set it that to 10. This will prevent users from changing their password away and cycling through 24-hour times, for example, so that they can reuse an old password that they know. So I'm going to go and click on OK. The minimum password length here, let's set it to 8 characters. All of these settings would normally be configured in accordance with the organizational security policies. We would want to make sure the policy meets the complexity requirement. At the same time, we could also go to account lockout policy. I'm going to go ahead and set the account lockout threshold to 3. This means that after 3 subsequent failed login attempts, the account will be locked. When I click OK, it sets the default settings for how long, 30 minutes in this case, but we could change that to something else. Now, this is a great way to thwart attackers that might enumerate a directory service like Active Directory, try to find the user accounts and try a bunch of passwords against them. After the third incorrect attempt, the account will be locked. Although these days attackers know that this type of thing, and they use password spraying techniques where they might try one password on one account and then move on to another account and try that. And once they're finished enumerating all accounts, they'll cycle back to the first one and try a different password, and that's done in an attempt to circumvent account lockout configuration. Okay, so now what we have done this within the default domain policy, it will flow down to Active Directory hierarchy to all computers. Now if we could go to command prompt on a given computer and run gp update/force to update group policy setting from the nearest domain controller, otherwise it could take 60 to 90 minutes. It really depends on your WAN replicating topology. If your Active Directory domain spawns a WAN, that will really determine how long it takes for a machine to get refreshed with the new password policy setting. In this demo, I'm going to be showing you how you can try to break into a web application by sending username password combinations to a web page. Specifically, we are going to try to crack a web form password page. So to do that, I'm going to be using our free meta-exploitable to internationally vulnerable web application. I've got this virtual machine downloaded. It's running, and it's running at 192.168.4.196 on my network. Remember, when you sign into your virtual machine, your meta-exploitable virtual machine with a username msf-admin and password msf-admin, once you have done that, if you issue the if command, you will be getting the IP address of your host. So that's what you would be running here as a virtual machine. So let's go back to the web page. Back here in Meta-Exploitable 2, I'm going to click the DVWA link on the left, which brings me to the login page where it prompts me for a username and a password, and I also have a login button. So I have 2 fields and a button on this web form. If I were to right click on the web browser on the page, we could choose to view the source page. And here we have got standard HTML document that is using a cascading style sheet for formatting. We've got the image source tag with the logo, and then from action here is passing the login.php, which is part of the URL to the web server using the HTTP post method. The method equals post for the form action. We have got some username and password text that's shown on the web form, and we have got 2 input types of fields. One is the text for username, another type is the password, which will mask what we are typing and as we are typing it in, and the name of the password with a maximum size of 20. And then we've got input type of limit, which gives us our button, which we have labeled with the value of login, and then form tag is closed. Pretty classic HTML document. Let's close that now. Attackers would need to know something about how the page is constructed in order to attempt to crack the credentials on it. Also, they will have to know the URL. So here at the top, you've got the host IP address, or it could be the name of a host or a fully qualified domain name slash dvwa slash login.php. So this is a PHP page that runs server side on our web server. If I were to enter an incorrect username and password, it returns login failed. Now this is important. We need to observe this behavior because in order for us to try to attack this web page, we need to know which username and password combinations did not work, and we can do that by verifying if it returned failed login. So that's important to know as well. I've downloaded the latest Kali Linux virtual machine image. Kali Linux is a pen testing tool. It includes many security tools that are built into the Linux distribution, one of which is called Hydra. I'm going to use the man command to view the manual page, the help page for the Hydra command line tool, because Hydra is a tool we are going to use to attempt to break the credentials on a web form type of page. Okay, so it talks about Hydra being very fast network logon cracker, which supports many different type of services. Well, that's interesting. We are going to use it to try to crack the username and password fields or in our web page form. So as I go down through this tool, all of the command line parameters are shown. We are not going to be using all of them. We are going to be using a few of them, like dash lowercase l, and then remember Linux is case sensitive, so lowercase l is different from capital L. So dash lowercase l means we either specify the login name that we want to attempt to crack the web page with, also a username. So if we have a file full of many username, we could use dash capital L and specify file name dash lowercase p. We then specify the password we want to attempt to try. Or if we have a password file with many passwords in it, we could use dash capital P and specify the password file. Okay, so I'll press Q to quit. There are other parameters, but we are not going to need to use them. So I'm going to change the directory to /usr /share/word list, and if I do an ls here, we got a zipped file up, a gzipped file called rocku.txt.gz. Well, I can use the su.unzip command to unzip the file that asks for the password for my Kali user. The password for Kali is Kali, the username and password is same. So if I now clear the screen and do an ls, we've got now roku.txt. This is a simple file. If you just show the contents that with cat roku.txt, the sample file contains many variations on things like passwords. We're going to use this as our password file that we are going to feed into our Hydra command, ultimately try to break into credentials on which page form. I'll press Ctrl C to stop that, and of course you can modify this file. Now if I cat this file to pipe the result into the grep line filtering command, I can look for specific passwords to see if they are already in there, like for the word password, and there are many variations on it, including just password itself in lowercase letters. Now the reason I'm doing this is because I happen to know that the username is admin and that the password is password for that sample web page. Definitely not following good practice password guidelines. So bear in mind that if your account lockout setting is enabled, let's say after 3 incorrect login attempts, the account is locked for a period of time that would stop the attack after it tries the first 3 passwords. Assuming they don't allow login to that web application, the command's going to look like this in Hydra. Then I specify the IP address of the host I want to attack, in this case 192.168.4.196. It could also be a DNS name. Then I'll specify dash lowercase l, so the login name I want to specify is admin. I don't have a file full of username, but I would just use a capital L instead and specify the file name. I'm going to use -P because I do want to reference the Roku file txt that we are here just looking at all the various passwords in it. So the HTTP method here is going to be an HTTP post form and then space, and in double quotes I'm going to give it a URL. We need to know the URL dbwa/login.php. Next thing I'm going to do is to specify colon equals, and I'm going to use a caret by shifting my number 6 key, and I'm going to put in the user in uppercase and caret again. What we are doing here so far, well, we are telling it that the origin PHP, we want to go into the username file and want to inject whatever is in the user variable. In this particular case, user variable is the name admin, which specified here on the command line. Otherwise, if we had a file full of usernames, we would keep replacing with the usernames of that file. I'm going to put it on the ampersand, and so the password equals, so that the password field on the web4 we are referencing, we want to feed into a variable, so that's going to be a caret symbol, uppercase pass caret symbol again. That's going to replace the password field on the web form with passwords of our Roku txt file. So the admin username will always be used, but we are going to be cycling through all the passwords. Then I'll put and login equals login. That's the login button. That's what it was named. Remember, when we viewed the page source :login failed, that's how we know that it did not work. That's our return message. And then I'll press enter, and before you know it, it'll already have quickly discovered that login for that web page is admin and the password is password. Now this may be painfully obvious to you already, but I'm going to state it anyways. Do not run these types of attack tools against sites that you do not own, or you do not have express written consent to run against attack, because running this attack is crossing the line. You could be prosecuted for it depending on what you're doing to it and where you're doing it from. So only do this in a test environment or as a penetration tester. In this demonstration, I'm going to be using the free community edition of Burp Suite tool to crack the credentials of a web page. So when we have form fields to ask things to remember, like usernames and password, we can inject ourselves as a middleman between a web browser client and that server, that we can gather that information, kind of like what we can do with the OWASP Zap tool. You can act as an HTTP proxy, and that's exactly what we are going to do here. So I'm going to go ahead and download and install the Burp Suite in Community Edition. All right, when I started the Burp Suite, I'm going to be asked to create temporary project or opening an existing project. I want to just work with the temporary project. I'm not going to save it, so I'll just click next. I'm going to use Burp Suite defaults, so I'm going to click Start Burp, and what I want to do here is go to the proxy tab on the top. Currently intercept is off. I want to turn intercept on. I want to act as a middleman, so that request to an web application go through Burp Suite. Now I could use a web browser and configure it to proxy through Burp Suite, or I could just open the browser built into it, which I will do. So open web browser. Now what it's done, it's already started to give me some results about the web browser session here. Now in my Burp Suite browser, I'm going to enter in the IP address of the web application that I want to try to intercept or even try to hack into, and then I'll press enter. Now it might look like it's taking forever. Essentially each request, each submission to the server is paused and captured by Burp Suite. Now in a totally separate browser, this is what the page should look like. Ultimately, we are going to be navigating to DVWA, where we have a username and password field on this login web page form. So back here in the Burp Suite, to continue on, I'm going to click forward, and we've got an HTTP GET request, and the host IP is shown here in Burp Suite. So I'll click the forward button on the Burp browser. That gives me meta-exploitable to web page now. So if I click DVWA, it looks like a thing that are paused once again. So let's go back to Burp Suite, and I'll click forward. So it looks like the GET request now reflects the login PHP page on that host. We even have some cookie information that's been intercepted here. So I'll just click forward here in the DBWA sample web page. Just pop the username and password and I'll click login again. Everything appears to be paused. Back here in the Burp Suite, this is how easily it was able to retrieve what I just typed in for the username of admin, password or password. Now, of course, the attacker would have to be able to position themselves for a man-in-the-middle type of attack such as this between a client and the server. That's much more difficult than just starting it. Not only that, the Burp Suite tool can also be used to analyze or troubleshoot activity related to web application. At any rate, if we were to click forward here, it would be complete the connection. And here in Burp Suite, if we go to HTTP history, we will have a little bit of a history above the connections that were made to that host and the URL, and whether the HTTP method was get or post. If I were to click on the options tab on that top, this is where we could configure proxy listeners. We mentioned here that you could have a different web browser proxy through Burp Suite, specifically port 8080. You can also add conditions down below for which type of client request that will be intercepted by Burp Suite, whether it is HTTP method or a certain kind. So if I click add, you could specify the match type, whether it's a domain name, IP method, HTTP method, URL, a file extension, a cookie name. The list goes on and on. So the Burp Suite is quite an extensive tool which works great with an HTTP interceptor. It can be used by nefarious individuals for trying to break into web applications, but it can be used to test the security of a web application as a part of vulnerability assessment. So that's just a little bit about how to use Burp Suite to kind of analyze activity on a web page form. In this demonstration, I'm going to crack an RDP password using Hydra tool. RDP, of course, is Remote Desktop Protocol. This is used for GUI remote management for Windows host. So I've got Windows Server running here already. What I want to do is to go to a command prompt, and I want to do from here is find out the IP address of this host is. So I'll type the IP config, and here we've got 192.168.4.167. So that is the host that I will be running RDP password crack against. But here we are being handed this on a silver platter. We know this is a Windows host, so presumably RDP is running on it and available for remote connectivity. But what if we don't know which hosts are up on the network, let alone those that support RDP? Well, that's why we have tools like Kali Linux, which consists of multiple command line utilities for testing security, such as Nmap, to scan hosts to a network to see which ones are up and running and which ports might be available. For example, if I were to say Nmap 192.168.4.1 through 170, let's say I want to scan the range of hosts in that IP range, and maybe I'll change my command so I have nmap dash capital P lowercase n, which means I don't want to perform a host discovery, and I'll press enter. So we'll give it a moment here to scan the network, and we'll see it if it discovers anything with port 3389, which would be indicative of RDP, of course. Of course, if we want to scan a little single host, we could specify it with its IP address and even a single change. We are looking for dash lowercase p, so RDP listens on port 3389. So I could issue this kind of nmap command, and I get a return listing that shows that state is open. That machine is listening on TCP port 3389. So that could then reduce my number of hosts that I want to potentially break into if I were a malicious user. Now, speaking of playing the part of malicious user, what they would do at this point? Well, the next order of business would be to make sure that we have a username or a password file that we want to apply against our newly discovered RDP host. Currently, if I issue the password print working directory command here in Kali Linux, I'm in the user share password list directory where I already unzipped a file for roku.txt. This is included with Kali Linux, and if I cat the roq.txt file, it is an enormous list of passwords. Okay, so we can use this as a password file. We want to try to crack passwords. So I'll press Ctrl C to stop that output. Now if I look at the manual page, the help page of the Hydra command, it gives me a listing of all the command line parameters that we could pass to Hydra command. And what I'm interested in notably is -l, where I can specify a login ID, a username in this case for RDP on a Windows host, or I could use a -L and specify a file containing many usernames. I could use -p and specify a single password in the command line I want to try, or -P in a file which we have the roq.txt file. So we have a couple of ways to run the Hydra tool. Now, of course, leaving an RDP port open to the public internet is never recommended for security reasons. It can be discovered with Nmap and potentially attacked by the Hydra command line tool, among many others that are out there and available. You might want to make sure that the RDP is only available in internal networks. Maybe you'll have to establish a VPN tunnel to get it to, or go through a jump box. And of course, at the user account level, use complex passwords, enable user account lockout setting, and you should be using multi-factor authentication to mitigate the type of attack we are about to jump in. Okay, so Q for quit. Let's make it happen. So I'm going to issue the Hydra command with -l, with that's a lowercase l, so that's the login name I want to specify here. I'm going to specify a user account of C Blackwell. Now I know that is a valid user account on that host. Otherwise, you could guess at the command line or use L as a parameter and specify a username -P. We know the file here on the current directory is called roq.txt. It's got all of our passwords in it, then RDP : / and the IP address of the host that I want to attack. Let's go ahead and press enter. Well, it doesn't seem like we're having too much of a luck. Of course, we could wait for it, but I'm going to press Ctrl C because I think that the username is C Blackwell and it's not working. Well, maybe I could try what I know is normally present on a Windows machine, such as an administrator account. Let's see if that's the case here. Yeah, that's what it is. I didn't take long for it to discover that login username administrator has a password of the word password in variation of it with ABC123 at the end. So that's potentially easy. It might be for a malicious actor to break into Windows host by trying a bunch of different password against the RDP port. Many Unix and Linux distributions store passwords locally in a file called shadow, and this is in the /etc directory. And what it does is it stores a hashed version of the used password, so it doesn't actually store the password itself. Modern Linux variants will use salting, which adds randomized data when generating the password hash to make it more difficult to crack. So essentially, we want to make sure that attackers cannot get access to the /etc shadow file where the hashed user passwords are stored normally in Unix and Linux environment. Because if an attacker can gain access to this file, if even an offline copy of the file, they can still run various attacks against it to try to determine what the original password was, even using rainbow tables. So in this case, we are going to use our free tool called John the Ripper and attempt to crack hashed Unix passwords. So I'm going to run sudo and I'm going to run tail/etc/password spelled PASSWD. Now this is a Linux file and that contains user account information. For instance, we have the user mbishop along with things like the user ID, the home directory location for that account, and all the login shell that they will have even when they sign in. But what they don't have is the file in the newer Unix and Linux distributions in the hash password of this account. Instead, clear the screen, you can see that running the sudo tail/etc shadow. Now here we have the entry for mbishop. Once again, this is to be expected, but what follows in the next field, and each field, by the way, here is delimited with a full colon symbol. That's what separates each field of information here, because we have password expiry info, we have the username, and what we are interested in, the password hash, which I've just selected here. Okay, but that password hash is in the result of entering the normal password and then it being fed into the hashing algorithm, which results in this value. But there are ways that we can try to crack this by feeding in lists of potential passwords and just comparing the hashes against what might be seen here. Okay, so what's going to do then, we are going to run the sudo because we want to run the elevated privilege commands. I'm going to run the shadow command, and here what I want to see is I want to combine the contents of /etc password and the contents of /etc shadow. I'm going to output that using my output redirection symbol. It's a greater than sign. I'm going to store that into a local file in the directory called creds.txt. The John the Ripper tool needs to have the contents of those two files in one file, and that one file here is our creds.txt. So once that's done, we are going to take a look inside creds.txt just to make sure everything seems like it's good to go. So cat creds.txt, yeah, it looks like it's a combination of what we have looked at in the individual files, so that's good. We are good to go there, clear the screen. The next thing we want to do is to make sure that we are aware of password list file or the files that we want to use. So for example, I'm going to head against a file under /user/word list, and this is a built-in password file. I actually decompressed it or unzipped it. It's called roku.txt. It's part of a Kali Linux, which is what I'm using. And if we look at the head of that file, just in the first 10 lines, that's the passwords. If I use the up and down key to bring up that command, let's say we actually use the cat command or shadow the entire contents of that text file, it would take quite a while for it to finish because we have got a ton of passwords here that can be used in a particular case to try to crack hashes that are really stored in /etc/shadow. Okay, so I'm going to press Ctrl+C to interrupt that. So now that we know the preliminary function, how do we make this all work? Well, I'm going to run the John command, John the Ripper dash word list, and what I want to do is I want to make sure I'm pointing to /user/share/word list/rocku.txt. And that's the file we have looked into. Now that could be a tiny file that you create, a text file with just a handful of common passwords. It could be anything, but in this case, I'm going to refer to that one built into Kali Linux, and the next parameter is the credential file that we created, creds.txt. Remember that was a combination of /etc password and /etc shadow. So let's go ahead and press enter, and okay, now we are going to run John --show, and we want to show the results of any cracked password hashes related to creds.txt, and immediately for user Kali we can see that we have found the password of Kali. For user 1 u1 we have password here, which is the variation of the word password, and the user that we looked at, mbishop. It's determined that the password hash was derived from an original plain text string of password abc123, so that's how incredibly easy it can be to start cracking Linux password hashes. Now, mind you, an attacker would have to access to combination of etc password and /etc shadow, but we are going to see some examples later of how easily it is to get files from a web browser interface. So an insecure web application might allow attackers to inject commands to execute server-side and return the results of sensitive files like etc shadow back to a web browser interface. And if an attacker that has this online, they can save those. They can do this password cracking offline, and then they could try to sign in with legitimate credentials to a web app. So that's why we have to be aware of how this works, and it really lends itself to telling us that we have very long complex passwords or ideally multi-factor authentication to mitigate these types of attacks. Probably the best way to break into someone's account, whether it's Twitter, whether it's for a Windows server, a Linux host, some website, is to trick them, whether it's tricking them into clicking a link in an email message, whether it's making a telephone call, or tricking them into providing credentials, or whether it's cloning a real website but having to run on a fake host together or harvest credentials. That's what we're going to do. We're going to harvest credentials using a tool that's included with Kali Linux called the Social-Engineering Toolkit. Social engineering is deception, it's trickery. So whether we want to steal credentials for someone's Twitter account, Facebook, or online banking, it could be anything. We first have to do is figure out what correct normal URL is that for website, because what we want to do is copy the look and feel. We want to clone into our own machine where we are running a small web server stack. We want to trick people into visiting our fake web server, which will look just like this, so they'll be fooled into entering their credentials and trying to sign in. So I've downloaded and I'm running the free Kali virtual machine in my local host, and what I'm going to do is enter the as you do command to run a privileged command, and I want to run SE Toolkit. This stands for Social Engineering Toolkit. I want the passwords for user Kali. Well, that's also Kali. And after I read what's on the screen, I can choose to agree or not agree with the terms of service. And with this tool, I don't even have to enter the command line parameters. I've got into the menu-driven system. Could it be any easier? So we've got a number of items such as social engineering attacks, penetration testing, and working with third-party modules for this tool. Well, I know I want to go into the number one social engineering attack, so I'll enter in number one and press enter. Now notice, by the way, our command prompt for social engineering toolkit or set now, then we get a second level menu where we have all kind of goodies like spear phishing attacks. Spear phishing means targeting attacks to specific individuals or try to trick them, for example, into clicking the link. Number 2 is website attack vectors. That's the one that we are going to do. Then we are got options whether follow in the menu for infectious media generation, mass mailer attacks. The list goes on and on. Let's get into the number 2, website attack vector. Okay. Then we have another sub-level menu. Do we want to run a Java applet attack, a Metasploit attack, credentials harvesting, which is usually what we want to do. So number 3, for credential harvesting, enter. And what I want to do is I want to clone the Twitter login page. So number 2 for site cloner. Okay, so it asks for IP address for the post. In other words, where do we want to direct the captured credentials? And that's going to be for the IP address for this local host 192.168.4.161. That's where I'm running Kali Linux. I'll press enter for the URL and want to clone. I will enter https://www.facebook.com/login because that's the site I want to copy or clone. And I'll press enter, and after a moment it's running on port 80 in this case on this local machine. So I just need to know the tricks by visiting my fake website, and whether that's through some kind of DNS poisoning or of a DNS server, or to redirect that DNS name to my IP. So I would have to have a public IP address on my attacker machine, or I could make that work through port forwarding, whatever the case might be. Or if you have control of the victim's computer, I might add an entry in their host file to redirect Facebook DNS name to my server. So this looks like a real thing, and of course, we don't have a certificate on our browser. It says not secure, but if I enter in a username and password and then I attempt to log in, it looks like nothing happened other than some kind of a glitch that occurred that didn't accept my credentials. So the user would normally specify the real credentials next, which you could then actually log in this case to Facebook. But let's check to go back with Kali Linux. Wow, looks like some stuff happened back here. So as I go back up, we have listings here for possible username field found where email specified was test user. That's indeed is what I logged in with. And when possible, password field found, and indeed the password I entered was test password. So we actually captured those credentials because I would have tricked a user to come visit my fake website, which looks like the real Facebook login. Now I've been redirected on and they are going to live. Give it a second thought. But naturally, I can now sign in as that user into Facebook. This is one of the reasons why user education, user training is very important. User needs to understand that if they get messages in their browser about a site not being secure, then that usually means something's up. It could be something as simple as website certificate expired, but still users must be educated to not to go to that site. It could be even entered a different URL IP address that matches what is in the certificate, or it could mean that this is some kind of a social engineering attack. Multi-factor authentication means that we have multi-authentication categories that are required before authenticating succeeds, and ultimately leads to the authorization to access a resource. So instead of something like just a username and password, we might in addition require some kind of authentication code and is sent to a user's phone, for instance. While there are many ways to enable MFA in different systems, in this particular demonstration I'm going to be using the Microsoft Azure cloud. If I navigate to the Azure Active Directory, I'm going to open my navigator on the left and go to the Azure Active Directory. And if I go take a look at my users view and open up the user in question, in this case I'm going to go to Bonnie Grace. Currently the user has an email address or a sign-in name and a password which I could reset if forgotten. But both of those items fall under a category of something you know, and therefore this constitutes single-factor authentication. If somebody can guess the password, and if they know or don't know the email address, they guess that as well, they could be in. So we might want to make it harder for people to break into these accounts. We want to enhance user sign-in security. That's where MFA comes in, because you have another category of authentication. Web applications will call it two-factor verification if it only requires two different categories, but it all works out to be the same thing. So what I'm going to do then is I'm going to go back to my users view here in my Azure Active Directory tenant, and I'm going to click as per MFA button on the top. That's going to open a new browser window which will list my users and their multi-factor authentication status. The default is when you create a new Azure AD account, MFA is disabled. However, we've got a few here that are enforced, which means it's been turned on and people have logged in with MFA. And we also have some that are enabled, which means MFA has been turned on, but that user has not signed in with MFA. For our subject Bonnie Grace, it's showing as disabled, so I'm going to turn on the check mark and select Bonnie Grace, and I'll click enable on the far right, and I'll just click enable multi-factor authentication button, and then it tells me that it's now enabled for that selected account. Perfect, I like it. So I'm going to click close, and for Bonnie Grace now we show enabled under multi-factor authentication status column. What we are going to do is sign in as user Bonnie Grace to see what it looks like for the first time as the user signs in after multi-factor authentication has been turned on, and then we log out and log back in again and get an overall feel for how it should behave. Okay, so in another web browser instance, I'm connecting to myapps.microsoft.com, although the URL has changed, and I'm going to pick the user Bonnie Grace. Her email address is here because she's signed in previously in this web browser. I still have to know the password for this account, so I'm going to go ahead and enter that in, and I'll click sign in, and then it says that more information is required, and this is because we have enabled multi-factor authentication. So I'm going to click next. So the first thing it wants to do is to determine how we should be contacted for the second factor authentication, such as having a smartphone or an office phone or mobile phones. So I'm going to choose mobile app, and I want to receive notifications in the application for verification. How, you might wonder, well, how is that going to work? we are going to determine that we will click on the setup button where we are going to provide a QR. So it gives me instructions. It tells me to install Microsoft Authenticator application. Well, I've got the install on my Android phone, but it is supported in Windows and Apple iOS devices as well. And I'm going to add a work or school account and then scan the image below. And if you don't have Authenticator application installed already, just go to your app store for your device and do that. Okay, so all I do is point my phone's camera to the QR and it knows automatically that the Azure AD tenant is Azure DevOps, and it knows that it's Bonnie Grace. It picks it all up from the QR. So I'm going to go ahead and click next, and I'll click next again. And what's happening on my smartphone right now is in the Microsoft Authenticator application, it's popping up and adding me to approve the sign-in requests. I'm going to tap approve. Let's see what happens here. Okay, verification is successful, taking me to the next step. Perfect. And step 3, in this case, I lose access to my mobile app. I can specify the details related to my phone number. So I'm going to go ahead and do that, and I'll click next, and finally done. So now I'm going to be signed in as Bonnie Grace after having initially set up multi-factor authentication back here in the Azure portal. So if I go back into per user MFA and take a peek at user Bonnie Grace, notice now it's showing under multi-factor authentication status column the word info. So let's sign out of Bonnie and let's go do a fresh sign in just so that we know MFA is working as intended. So of course I need to have my smartphone handy here in order to approve the request. So I'm going to select the username, and I still need to know the password, and then I'll click sign in. And it says approve sign-in request for the same thing I have popped up on my smartphone. So I'll just tap approve and we'll be off of the races, as they say. Looking good. Stays sign in? No. Okay, so now we have successfully authenticated multi-factor authentication for this user Bonnie Grace. Now you really want to pay attention to enabling MFA for powerful administrative accounts. Really, if you can swing it, you really should enable MFA for every user account. It just really is a simple thing that you can do and to greatly enhance sign-in security as opposed to just using the username and password. Yes, it's a bit of an effort to set up, and yes, it might be a few more steps for users and a bit inconvenient, but that's always the case when things are more secure. So let's just do one more test. We are going to see what happens if we pretend that we are going to have our smartphone application available. So I'm going to go ahead and sign out as Bonnie, and of course I'm going to sign right back in. So I'll select your username and then the password and choose sign in. But this time when I get the approved sign in request in the screen, I'm going to choose I can't use my Microsoft Authentication application right now, at which point I get verify your identity screen. So we could choose the instance to send an SMS text message to be configured phone number. A user might get a new smartphone, move to a new SIM card, so they have the same phone number but not have the application configured. So this can be useful in that kind of scenario amongst others. Okay, so I enter the 6-digit passcode that is texted to my phone, and I'm going to click verify, at which point we just proceed on and we are signed in now with MFA. So in this course, we have examined how to discover and mitigate authentication vulnerabilities using tools like Hydra, Burp Suite, and John the Ripper. We did this by exploring authentication and authorization, reconfigurations, hashing credentials, and encryption over network. We examined how to analyze plain text credentials, and we deployed password policies with Microsoft Group Policy, and we cracked web form passwords with Hydra and Burp Suite. Next, we cracked RDP passwords and Hydra and Linux passwords with John the Ripper tool. We used the Social-Engineering Toolkit, or SET, to steal credentials, and we enabled multi-factor authentication, or MFA, for Microsoft Azure credentials. Hope you've all liked this video and feel free to give suggestions. Bye now.